Lesson 88 teaches about what are called separable differential equations. So there are several different types of differential equations. In this case, we're going to be looking at separable, which means we can separate the y's from the x's. So you can get all y's on one side, including the dy, and x's on the other side, including the dx. So this one is pretty simple to start with. So what we do is we separate the y's and x's. So we're going to have to multiply both sides by dx here, because this is dy over dx. And so we have dy is equal to 4 cosine of x dx. Now, in order to solve for y, we're solving for y, which I should have mentioned earlier, we need to integrate both sides. So we're going to integrate both sides, and we're going to get a general solution here. Later on, we'll look at what are called specific solutions. A general solution will still have a plus c within it. Specific solutions, you actually want to find the value of c. So the integral of dy is simply y plus c, and the integral of 4 cosine x dx is 4 sine of x plus c. Now these c's are just constants, so what we can do with these constants is they're not necessarily the same, so maybe we should put a c sub 1 and a c sub 2. If we subtract c sub 1 from both sides, we'll have a constant minus another constant, which those are just, we don't know what they are. It doesn't matter what they are. So a constant minus another constant is yet just another constant. And so we can write our general solution as y equals 4 sine of x plus c. And that's what our answer is. And we've done this before when we think through integrals. If we knew the derivative of something was 4 cosine of x, we would have known we could anti-differentiate and find out that the original was 4 sine of x plus c. Moving on to the next one, written a little different way, but it's going to be the same idea. The slope of a certain curve. Well, when we see slope, especially in calculus, we know we can think of dy dx, or the derivative. The derivative is the slope of the tangent line to the curve, any point in the curve. And so we have dy dx equals twice the value of the x-coordinate everywhere. So twice x, or 2 times x. And so then it says find the equation of the curve given that it passes through the point 1, 2. We're familiar with derivatives. We know that if the derivative of something is 2x, that should have to do with a parabola, which is x squared. We'll show what we're doing with our separable differential equations, but we could think through this and really get to an answer fairly quickly, I believe. But we're going to go ahead and do what we are trying to practice here in this lesson. So we're going to multiply both sides by dx. So we have dy equals 2x dx. And now we want to integrate. The integral of dy is just y plus c sub 1 equals the integral of 2x is x squared plus some c value. And once again, we can write this, we can take the c sub 1 to the other side, so actually get y equals x squared plus some c value, which we knew that it had to be a parabola. Now, what we also want is we want the specific. So our first example was a general solution. Here we want a specific parabola that goes through the point 1, 2. So all we have to do now is find the value of c. So we're going to plug in the specific point. And we get 2 equals 1 squared plus c, because we're putting 1 in for x and 2 in for y. Subtract 1 from both sides, c is equal to 1. So the specific equation that fits this is y equals x squared plus 1. All right, let's take a look at the next one. Find the general solution to the differential equations x dx plus y dy equals 0. This is still definitely differentiable. We can get everything with y on one side and everything with x on the other side. So let's go ahead and subtract x dx from both sides. So we're separating it, and we get y dy equals negative x dx. We are going to integrate, which gives us 1/2 y squared plus c sub 1 equals negative 1/2 x squared plus some c value. In this case, we can multiply both sides by 2 to get rid of these fractions. And remember, these are just constants, so a constant times 2 is still just a constant. We don't have to put the 2 in there, so we have y squared plus still some c value, some constant, we'll put c sub 3 because it is different, equals negative x squared plus c sub 4. We'll subtract this from both sides, which gives us y squared equals negative x squared plus some c value. And then we really recognize this as a circle because we have an x squared and a y squared. We can bring the x squared over to one side, add x squared to both sides. We have x squared plus y squared equals c. So this is a circle centered at the origin with the square root of c will be the radius. And that's the solution. We could solve for y and get two different equations, but there is our answer. All right, the last one, given the differential equation, y prime equals 4x squared y squared. Find the particular solution y that passes through the point y, r1, negative 1. So we have our original equation. So there it is. Instead of writing y prime, we're going to go ahead and write that as dy dx, so we can separate that. And so what we'll do is we'll get the y's on one side and the x's on the other side. So we will multiply both sides by dx. And you could do these two steps at once if you wanted to. And then divide both sides by y squared. So we have dy over y squared equals 4x squared dx. We normally, when we look at these things, we put y to the negative 2, and we have 4x squared dx. Now we are going to integrate both sides. This will give us y to the negative 1, and multiply the outside by negative 1, plus some c value, equals, this is going to be 4, we'll have an x cubed, we'll have to put a third out front here, plus some other c value. So we can bring the constants to one side, so we have negative y to the negative 1 equals 4/3 x cubed plus some c value. Now we want to go ahead and solve for y here. Probably what I would do is, well, let's first just think of this as negative 1 over y equals 4/3 x cubed plus c. We can get rid of our denominators by multiplying by the common denominator. So let's go ahead and multiply, and I'll write that down here before we come up to the top. There's a y there and a 3, so let's multiply both sides by 3y. which will make this a little easier to work with for a bit. So on the left here, we'll have negative 3. And on the right side, the 3 will cancel, and we'll have 4x cubed y plus 3yc. Now we want to solve for y, so let's go ahead. We notice here we have a y on both sides, in both terms, so we can factor out a y. So we have negative 3 equals y times 4x cubed plus 3c. Now I do want you to realize we did get rid of denominators when we multiplied by this 3y down here in blue. But another thing we were doing, we were getting all the y's to one side. All right, so solving for y, we divide both sides by that value, 4x cubed plus 3c. So we have negative 3 over 4x cubed plus 3c. Now 3c is just a constant again, so we can put another c value, and maybe we should have put a c sub 3 here. I kind of thought we were done dealing with a c, but we're ending up changing it again. So y, I'm going to put the y over here, actually equals negative 3 over 4x cubed plus some c value. So there's a general solution, but we want to find when it passes through the point 1, negative 1, so we need to find the correct c value. So we're going to plug in, so we put negative 1 in for y, equals negative 3, 4, we put positive 1 in for x, and then we solve for c. So let's come up here. I think we can finish this off, so let's just rewrite this without. So we got negative 1 equals negative 3 over 4 plus c. I'd probably just cross multiply here. Multiply both, actually just multiply both sides by 4 plus c. So negative 1, I'll write that in here. 4 plus c. Wow, I'm backwards here. And then 4 plus c. Over here it cancels. We have negative 4 minus c equals negative 3. Add c to both sides and add 3. So plus, add c, add 3, add c, add 3. And we get, these cancel, negative 4 plus 3 is negative 1 equals c. And so finally our answer is y equals negative 3 over 4x cubed minus 1.